Does your company need a welding engineer? Or are you a welder, welding supervisor, welding inspector, or even an engineer in another discipline who's been put in charge of welding engineering functions but feels completely overwhelmed? If you answered yes, you're not alone. We see this problem every day, especially with small to medium-sized fabricating businesses. Everyone knows that having a great welding engineer on staff is a game changer. They're the ones who are best suited to ensure weld quality, improve welding productivity, and dramatically lower your overall costs. But here's the reality. Degreed welding engineers are in high demand and short supply, and most companies simply can't afford to hire one. Those who can afford one are faced with the reality that industries like automotive and aerospace tend to gobble up any available welding engineers, paying very high salaries and recruiting them right out of top schools. So, what's the solution? The secret is this. You don't need a 4-year degree to perform the core functions of a welding engineer. In fact, an inexperienced degreed welding engineer might not be as useful as a professional with a few years of on-the-job experience. It's that real-world exposure to problems, a true understanding of the challenges of the shop floor that, coupled with the right knowledge, turns good people into great assets. Many companies have found that by providing the time and resources to their ambitious and dedicated welders, supervisors, or QC personnel, they can empower these individuals to handle the vast majority of welding engineering tasks. This strategy has allowed companies to improve their operations, increase throughput, and achieve significant cost savings without ever hiring a degreed engineer. So, what exactly does a welding engineer do? They are responsible for designing, implementing, and overseeing welding processes. They ensure the structural integrity of welds, select the right materials and techniques, and are the go-to person for weld troubleshooting. They are the ones who make sure that every weld is up to the required welding quality standards. They develop and qualify welding procedures, work with welder qualifications, and are critical in preventing weld failure. We've created a document called The Essential Body of Knowledge for Aspiring Welding Engineers, and it outlines the key areas you need to, or whoever will be handling welding engineering tasks to master. You can download a free copy by following the first link on the notes section of this video. This isn't about learning complex calculus or differential equations. It's about practical knowledge that you can apply immediately. Knowing what to learn is key. For the average welding professional, learning just 8 key areas will prepare them for 80% or more of the typical duties of a welding engineer. Let's break them down. Welding processes. You need a sound understanding of the common arc welding processes, like gas metal arc welding, flux core arc welding, and shielded metal arc welding, but also a basic understanding of other processes like stud, resistance, or laser welding. The key is knowing which process to select for a job and understanding the quality and cost implications of each. One of the biggest mistakes made in welding is assuming that a welding process should be selected based on the equipment that is available in the shop, rather than doing a proper financial analysis if a welding process requiring different equipment may be the logical choice. Sometimes a substantial capital investment in equipment will generate significant savings on a given job due to higher efficiency and productivity. Metallurgy and welding metallurgy. This is crucial. You must understand how metals react to heat and stress. Knowing the effects of heat treatment and how to prevent things like weld cracking is vital for ensuring long-term performance and reliability. A welding engineer is also an expert in welding metallurgy, which is related to the microstructural changes that occur due to the heating and cooling cycles of welding. Many failures, like hydrogen-induced cracking, occur due to the lack of process control. Welding engineers are responsible for ensuring that welders follow welding procedures and other work instructions without deviation. A good welding engineer does not only create these controls, but is also able to explain clearly to the shop floor why they are necessary. Welding procedure development. The ability to develop and qualify a welding procedure is a core responsibility. This involves knowing the necessary components of a welding procedure specification, and more importantly, the effects of all essential variables like amperage, voltage, travel speed, and many more. Troubleshooting. Problems happen. A good welding engineer can troubleshoot welds by understanding the root causes of discontinuities and defects. Being able to understand if welding defects are due to welder skill, welding equipment issues, or base material condition is one of the most impactful responsibilities of the welding engineer. Having a systematic approach to troubleshoot welding-related problems can save companies thousands in lost welding productivity. Failure analysis. When a weld fails, you need to understand why. Being able to analyze a failure will help you implement corrective actions and prevent the problem from happening again. It is a welding engineer's responsibility to ensure that every failure becomes an opportunity to improve. Learning from mistakes and improving work instructions is part of continuous improvement. Good welding engineers need to master failure analysis. Welding codes and standards. You need to be familiar with the codes that govern your industry, such as AWSD 1.1, API 1104, ASME Section 9. This ensures your work meets the required quality and safety standards. A welding engineer must also be able to understand customer specifications, which in many cases are more stringent than structural welding codes. Weld and joint design. This is about more than just reading a blueprint. You need to know how to select the right joint type for a job and understand how proper design can reduce problems like distortion and save on costs by optimizing weld volume. Welding economics. This might be the most overlooked area. Understanding the welding economics of a job, from filler metal costs to labor time, is what allows you to make decisions that truly impact the bottom line. Welding engineers are mainly concerned with ensuring quality and that production lines continue to work, but many times fail to optimize welding operations for cost reduction. It is the welding engineer's responsibility to establish baselines for cost and to track the efficacy of process improvements. So, as you can see, becoming a top-tier welding professional and performing the functions of a welding engineer is completely attainable, even without a formal degree. The information is out there, and with a little desire to learn, you can get it. The goal is to provide exceptional value to your company, whether you're a welder on the floor or a supervisor in the office. This knowledge will not only help you advance your career, but will also make your employer's operations more profitable. If you want to dive deeper into any of these topics, make sure to visit our website, weldinganswers.com, for more free resources and guides, including our technical guides on how to develop welding procedures, learn welding symbols, and weld troubleshooting. Thanks for watching. Don't forget to like, share, and subscribe for more answers to your toughest welding questions. See you next time.